Look, I know this is crazy, but for years now, I've been trying to reverse engineer these smart meters. But there's one thing I haven't been able to figure out. Let's start with what I do know. They report their data back wirelessly across a vast mesh network which spans the city. They're time synchronized and hop across the radio spectrum, relaying their messages back. They broadcast all kinds of things, like their GPS coordinates and the last time power went out, which seems to be more than we'd like. But the one thing that keeps me up at night, torments me every time I walk past a smart meter, is deciphering the power readings. The one thing I know for a fact they send back that I've never actually seen. Until recently, all the messages I received using my software-defined radio were relatively easy to decode. Staring at the data was enough to figure it out, shuffling ones and zeros around until it made sense. Then I received a message that changed everything. But it's going to take a lot more than staring to figure this one out. A while back, I shared it on GitHub after making a video about this new data. I hoped someone out there would see it and tell me what I was missing. It's happened before with timing information in messages I couldn't fully decode. A random email arrived with the solution. I went as far as offering a bounty. I would give away my prized smart meter possession, the Collector, complete with its Intel-based computer running Microsoft Windows. This time, though, no one turned up to save the day. Now, this right here is a hidden workhorse of the smart meter network. All the meters transmit to relay stations, and those contain a special modem. It's able to speak the wireless smart meter language and translate to computer signals over these ports. What if I could somehow trick this device to spy on the network and show me what it hears? Would it decode any power readings? I shared details on modifying one of these modems for that purpose. So far, no one has seen a power reading come across, that I know of. A few years back, I thought I would extract the meter's hidden instructions, called firmware, from its brain, a microcontroller. I was able to use custom tools to get a copy, and some closed source analysis software to try reverse engineering it. The analysis software needed more custom code written to be useful, and I didn't want to invest any time writing tools for software we have to pay for. The firmware itself is also large and complex. To make real progress, I would need a way to share it with the world. A simple extraction method and free software anyone can use to analyze it. Inside almost every device you use is code, and a small computer that executes it. These computers are called microcontrollers, and they run this code, their instructions, almost instantly when power is applied. It's like a phone with only one app. They have a single task: operate the refrigerator, microwave, or dishwasher. Even if your appliances aren't connected to the internet, you can bet there's a microcontroller inside running a set of instructions programmed in by the manufacturer. Those instructions are the golden key. If you can get them, you can see exactly how the device operates. For a toaster oven, those instructions are probably boring. For smart meters, there's a lot we could see. The meters can transmit their data on any one of 240 separate channels or frequencies in the 902 to 928 MHz spectrum. They hop around changing channels about every half a second. This pattern appears to be random, but nothing ever is. It's determined by a mathematical function using the network ID of the meters as its seed or starting value. If we knew this secret formula, we could hop along with the meters, drastically lowering the cost of equipment needed to listen in. Or transmit spoofed messages. When a power outage occurs, before the meter powers off, they send back a message letting the utility know. They're able to do this thanks to a large capacitor inside that stores enough energy for this final last gasp message. What if an attacker spoofed a massive outage broadcast? Could the rest of the utility system deal with that? How about real power fluctuations on the grid? A lot of meters contain a massive switch inside. If you send them the right message, you can turn anyone's power off. Just like that. So the question I asked myself was, how can I get the meter's instructions, its firmware, into as many people's hands as possible? The more people who can take a look and analyze it, the more likely we are to discover vulnerabilities in the system. The idea of a library hit me. A firmware library where anyone could check out a copy of firmware to analyze. The same way you go to a library and check out a book to read, then return it. Libraries lend ebooks too, so why couldn't I lend out firmware? Like a library, I have a catalog of smart meters on a shelf. As long as I track who borrowed a specific meter's code and only loaned out one at a time, why couldn't I build a library of devices so everyone doesn't have to buy their own meter to get a copy? To answer that question, I had to read the legal findings in the Internet Archive library case. You might be familiar with the Internet Archive as the place you can go to view historical versions of websites. It's an amazing resource to find older material that a company might have removed, or changes they made to hide something they were embarrassed about. The Internet Archive also has a library where you can borrow books for free. Thousands of them are available, but book publishers tightly control the purchase of ebooks or digital copies and the licensing rights around loaning them out. A book is a book, but not an ebook. So the Internet Archive came up with a creative workaround. Instead of dealing with publishers and all this ebook pricing nonsense, they personally digitized thousands of books. People operate machines, endlessly flipping pages to scan them in. Then they put those books into double-stacked shipping containers. Now they had one digital copy of the book they could loan, the same way they could loan the physical copy they owned. If they only loaned the digital copy to one person at a time, it would be the same as loaning one physical book out. This is known as controlled digital lending and is from a 2018 paper on the subject. The belief was if you maintain the owned to loaned ratio, you would be fine. The Internet Archive had been doing this for years to the frustration of book publishers. They also offered programs for local libraries to make use of their digital archive. This way, the smaller libraries wouldn't have to deal with the ebook licensing programs. As their system got bigger and bigger, the impact to the publishers couldn't be ignored, and a lawsuit was filed. It's possible the straw that broke the camel's back was during the COVID lockdowns, when physical libraries were temporarily closed. The Internet Archive decided to remove their one-to-one ebook to physical book limitations in the name of the public good. They would loan out books to anyone who wanted to read, since public resources weren't available. As they say, no good deed goes unpunished. The lawsuit accused Internet Archive of copyright violations. By scanning the physical books and converting them to digital versions, they had transformed the original work without the permission of the publishers. This transformation was a violation, and the court agreed with the publishers. Scanning a physical book and loaning it to someone is not the same as loaning a physical book by mailing it. Mailing is legal. Emailing isn't. This was the same concept I was going to use to build my firmware library. I keep a physical copy of the smart meter and loan out a digital one. This ruling by the court in the Internet Archive case pretty much blows that idea out of the water. But reverse engineers don't give up so easily. Another group of people are well versed in getting around laws limiting their rights to hardware they own. Gamers. They came up with a wonderful workaround in the form of a console mod chip. Almost every game console is a locked-down piece of hardware. It will only do what the manufacturer wants. Even though you purchased it, you don't really own it. Say you want to play a game on it other than one the manufacturer has blessed. Not possible. It won't run that code. Even though most new consoles are just glorified computers, their operating systems block you from running your own applications. A mod chip is a small device that's installed inside the game console to unlock it, freeing the hardware and allowing you to run your own programs. And best of all, it's completely legal. The only thing a console manufacturer can do to try to prevent it is make the system harder to hack. They can't use the legal system to attack you. Now, we all know that's not entirely true. They can still send the flesh-eating lawyers, but it seems they won't really have a case against you. What if there was a smart meter mod chip? A way for anyone who gets their hands on a meter to unlock it and get a copy of its secret code. I frequently find myself in the garage contemplating how we are even in this situation to begin with. How have we deployed these massive utility systems funded by government and the public as completely closed source? Corporations owning all the source code, locking us into aging systems with vulnerabilities no one can see until it's too late. Energy is a form of tax, after all. It's not like you can get out of paying for it. It might be on the same level as food and water. Without energy, people die, freeze to death in the winter. Why have we chosen to allow for-profit companies to extract shareholder value from a system people are forced to pay for? System upgrades and security are not the primary goals for a company that needs to provide maximum shareholder return. Extracting every ounce of value from an aging system is. The playbook for these companies is crystal clear. Run the systems into the ground and pray for an external event. Hurricanes, tsunamis, heat waves, cold fronts, terrorists, anything so they can run to the government with their hands out, asking for assistance due to this unforeseen event. And who pays for that assistance? You. Another tax, while the corporate profits are kept. This cycle must be broken, and it won't happen by asking nicely. After all,
the only thing power respects is power. And whenever you find a man who's in a position to show power against power, then that man is respected.
I propose we guerrilla open source these systems. It's like standard open source, but done unconventionally. We extract all the code, reverse engineer it, and publish how it works. If these closed source systems are secure, there should be nothing to worry about. In the beginning, since I can't build a digital library and loan you the firmware, you'll need to get access to a Landis & Gyr Gridstream smart meter. You'll also need a Raspberry Pi Pico, a small microcontroller we'll use to read out the firmware in the meter. That firmware has a lock on it, like a 7-wheel combination, with each wheel having 256 possible values. That's billions and billions of combinations. But don't let that scare you. By simply following this wiring diagram and plugging the Pi Pico into the USB port on your computer, you'll have everything needed to extract the firmware. Then it's a matter of entering these commands. They unlock the chip and prepare it for extraction. And that unlock code? Seems they just set it to all zeros. Easier for the engineers to remember, I imagine. I've blurred out part of this, but you can clearly see text in the extracted firmware. These bits of text are called strings, and they are predetermined messages programmed into the smart meter. This is great news for us. It means the firmware isn't encrypted. Not so great for the Landis & Gyr guys. If you're still here, I'm assuming you're the kind of person who won't be satisfied merely watching a video. You want to join in on the fun. So let me detail what you should look at purchasing. For extracting your own copy of firmware, you need a Landis & Gyr Gridstream smart meter. These are ones I know to contain the M16C processor, which I'll be reverse engineering. eBay is a good place to look, but if you're having trouble sourcing one, reach out on the RECESSIM Discord channel. You'll also need a Raspberry Pi Pico, some headers, and a cable. If you don't care about making it removable, you can just solder the Pi Pico directly to the meter. Now, of all the research I've done, what I find most rewarding is receiving smart meter broadcasts wirelessly using a software-defined radio. This is undetectable by any power utility or manufacturer and allows you to listen in to the communications of these devices. I wouldn't say this part is plug and play, you'll have to spend some time learning, but the reward is an ability to listen in on digital conversations no one ever expected would be heard. The thing to understand when purchasing SDR hardware is how much of the spectrum it can listen to simultaneously. Low-cost RTL SDRs are great to get started and listen to about 3 MHz at one time. If we measure in FM radio terms, this means you could record all stations from 92.7 to 95.7 simultaneously. You can then play back this recorded data, selecting an individual station to decode.
Compare Power is here to unscrew Texas from misleading energy company promotions.
Pretty impressive, considering an FM radio can only listen to one at a time. A Hack RF can capture 20 MHz of spectrum, which means you can record all of the FM radio band and then play back any station you want later. But why does receiving more bandwidth matter? Why not just tune the receiver to your specific meter? If you recall, the smart meters operate in the 902 to 928 MHz band, and they hop around all the time to different frequencies. More than 140,000 hops per day. And because we don't know that hopping pattern, to see all the messages that might be transmitted, we need to listen to all channels at the same time. For that, we enter a different price bracket of SDR. A Blade RF, Edis USRP, or Lime SDR is needed. But assuming we figure out the hopping pattern by reverse engineering the firmware, something as cheap as the $30 RTL SDR could be used to listen to your own meter. Or your neighbor's. In the next video, I'll share the free software tools we're going to use to make sense of this extracted code. I hope you follow along and join me reverse engineering. Remember that corrupt systems don't change in committee meetings or around fancy boardroom tables. They change because people like us destroy those systems.
Who else is going to change the world, Marty? Greenpeace?